Hello and welcome, and today we're going to look at functions, which is the third topic of quadratics. So, what is a function? Well, a function is a relationship. It is a relationship between the input and the output. So let's say I had a linear function of 3x plus 8, and it's called f of x. Now, it's called f of x because f is our name of the function, so we're naming the function f, and here we got our input. So if this was f of 1, then the x would be replaced with 1 to give us 3 plus 8, which is 11. So f is the name of the function, the 1 is an input of the function, and what we get from the input, we get also the output. Now input and output are called in mathematics the domain and the range, where the domain is input and the range is output. Okay, so we got functions f and g, where f is 2x minus 10 and g is x squared minus 9, and x is a set of real numbers. Now, what does that mean? This means that x is any number that is a 1, minus 1, a square root of 2, a minus square root of 2. It could be irrational number, a rational number, but what this means is that it's all the numbers except the numbers like a square root of minus 1, which cannot be done, at least in pure maths. So here we are trying to find an f of 5, so the input of the function f is 5. So what happens is we replace the x with 5, to give us 10 minus 10, which is 0, which is our output or range. Now the input of function g is 10, so we get our gx equals to x squared minus 9. Our input is 10, and we square that because it's x squared, minus 9 is going to be 100 minus 9, which is 91. Now in the last example, we have the function f equal to function of g. So f of x equals to g of x. That means that we equal two functions together. This one is f of x and this one is g of x. So what happens now is we can see that this is a normal question of solving the quadratic equation, and we know that this is a quadratic equation because it has x squared in it. So we get all the things to the left hand side or right hand side to make it equal to 0. What we get is 0 equals to x squared minus 2x plus 1, and now we can use any of the methods, which are factorization, quadratic formula, or completing the square, to solve the following equation. Now we do in this question, the function f is determined as f of x equal to x squared plus 6x minus 5, where x is a set of real numbers. So write f of x in the form of x plus p squared plus q. So we can see that this is in the form of completing the square, and we're going to complete the square of the function f of x. F of x equals to the following equation, and now we're going to complete the square. Now complete the square, we used a formula for it, and it is as following. So we got the formula and the coefficients, so now we can just plug in the, so it will be like this and like this. So we have completed the square. I've done the exercise part of A. Now for the part B, we have hence or otherwise find the roots of f of x, leaving your answers in a third form. So the word hence here, it means use the previous answer, which is in part A, or we can do it otherwise, so we can start from scratch. This means we do not use the answer from A, and we find the roots from the beginning. But we want to use the answer in part A because that is going to speed up things. So what the question B wants us to do is to find the roots of the function of f. So the function of f is x plus 3 squared minus 14. So we set f of x equal x plus 3 squared minus 14 equal to 0. So we can plus 14, we can square root both sides, we can minus the 3, and it tells us to leave it in a third form, so we leave it in a third form, and we have solved the equation for f of x. Now for C. It says to write down the minimum value of f of x and state the value of x for which it occurs. This is after we complete the square. So we have to make sure that this equation is the lowest possible. So this part here will always be positive because it's squared. So to make that thing equal to 0 is to make x equal to minus 3. So when x is equal to minus 3, f of x is equal to minus 14. The minimum value. So what happens here is that the x plus 3 squared is either greater than 0 or equal to 0. So if the result was not minus 3, then we would have it greater than 0, but if it is equal to 3, then it is equal to 0, and therefore the minimum value is minus 14, because if we put the value of not minus 3, then the function inside that bracket is squared, and we don't want that because it just increases the value of the bracket, and it is not minus 14, it will be greater than 14, and we don't want that. We just want to input x equals minus 3 so that the squared value is 0, which is the lowest possible, and therefore we get minus 14 for the minimum value. Now we got another question whether the function of x is the following and x is a set of real numbers. So here straight away I can see that these ones have a common factor, and this common factor is x cubed. Now how does this help us? This helps us because if we do x cubed squared plus x cubed 7x cubed minus 8 equals to f of x, then what happens is that we can see that this represents a quadratic equation, and we can solve it by factorization, quadratic equation, or completing the square, because if we make let x cubed equal to y, then what happens is that y squared plus 7y minus 8 f of x. So by changing the x cubed to y, we have an easier way to calculate the y squared plus 7y minus 8 than we would do with x to the power of 6. So if you can see the relationship between here and here for those two, then you can use let x cubed or another power to be equal to y to make sure that it's an easy form to factorize. Now I'm going to use the factorization method. So minus 8, 7, 1, 8, 2, 4, and that will be 8 minus 1, so y minus 8, y minus 1, so we set it to 0, because when we want to solve for x or y, we set it to 0, and because we changed y into x cubed, I mean x cubed into y, we have to change y into x cubed. So now we set them both equal to 0. So cube root of x is 1, and cube root of 8 is negative 2. Okay, so that's how you deal with the x to the power of 6. If you see and spot a pattern here, then you can change them to y and solve it easier. So now we're going to do the exercise questions. So question 1, using the functions f of x, g of x, and h of x, find the values of. So f of 0 plus g of 0 plus h of 0. So basically in our f function we replace 5 and the x with 0. So whenever there is 5x plus 3 for the function of f of x, we replace that input with 0, and now we have to add. So add another function, which is g of 0. So the input in a g is 0, so g of x changes to g of 0 to be 0 squared minus 2, and now we add h of 0, and h of x is square root of x plus 1, and square root of x plus 1 for the h of 0 will be 0 plus 1. And now we can normally solve this. So 0 plus 3 plus 0 minus 2 plus square root of 1, which is 1. This will be minus 2. Oh no, actually plus 2. So the functions here, f of x, g of x, h of x, all had x's to replace with 0 and have been added together to give us a value of 2. And now the function f of x equals to 10 minus 15x, and we need to find all the roots of 10 minus 15x. So when f of x equals to 10 of minus 15x, and we have to find the roots, what happens is that the roots of the function are the values of x for which f of x equals 0. So f of x equals 0, so 0 equals to 10 minus 15x. And now we can solve it normally like in GCSE, so 15x equals to 10 and x equals to 10 over 15, which equals to 2 over 3. So here we got f of x and g of x, where x is a set of real numbers. So what happens here is that we need to find the three values of x for which f of x equals gx. So f of x equals gx. That means to equate the functions together. So function of f and function of g, and we have to solve the following. Now to solve the following we need to keep all the values on the left or right hand side. I'm gonna go with left hand side, and we have to solve the following. So first of all, we always look for the common factors, and in here it will be x. And now we have to solve the following in the brackets. So here I will use factorization. So in here 2 times 30 is 60, and we have to find out what multiplies to 60 and add to get minus 17. So we write out all of the factors, and it is minus 12 and minus 5. We split the minus 17x into minus 12x and minus 5x plus 30. Now we treat those equations as separate. So 2x is the factor of 2x squared minus 12x. So that's x minus 6. And here it's going to be minus 5 and x minus 6. So here we get x, 2x minus 5, x minus 6 equals to 0. And here we equal everything to 0, because one of them has to be equal to 0 for the equation to be equal to 0. So x equals to 0, x equals to 5 over 2, and x equals to 6. And there it is. We have solved f of x equals to g of x, the three roots that we wanted. Now we have the function f is defined as f of x equals to x squared minus 2x plus 2, where x is a set of real numbers. Write f of x in the form x plus p squared plus q, where p and q are constants to be found. Now when it says p and q are constants, this means that these are the values that never change. So the constant could be a 1, it could be a 3, it could be a pi. So that is just any number. The p and q is just any stable number. And this part of the equation looks familiar. This means just completing the square. So here's the completed square formula. So the following will be the following, where we plug in the a equals 1, b equals minus 2, and c equals 2 into the formula of completing the square. And we get the following, which is x minus 1 squared plus 1. And this is in the form of x plus p squared and plus q, where p equals to minus 1 and q equals 1 are constants to be found. Now, in a part B, we can use our answer, which is means hence. Hence means that we can use part A to do part B, or another previous part of the question, and otherwise means we can do it the other way, but it will be longer. So explain why f of x is greater than 0 for all values of x, and find the minimum value of f of x. So why f of x is always greater than 0 for all values of x? Well, to explain that, we had to complete the square. Now, we had to complete the square to be in the easier form to explain. Because if we got x minus 1, so that's part B, that's part A, squared plus 1, which is f of x. This part will always be positive, so it will be greater than 0 or equal to 0 because it's squared. And because it's squared, we say that x minus 1 squared is always equal to or greater than 0. And because we add 1 onto 0, or value greater than 0, then f of x will be greater than 0, and the minimum value of x minus 1 squared plus 1 is when x minus 1 equals 0, so x equals 1. When x equals 1, 1 minus 1 squared plus 1 equals 1, and this is our minimum value. So minimum value is 1. Now this is a bit long, but you get the idea. Now the final question, which is the function of f is defined by f of x equals to 3 power of 2x minus 28 times 3 to the power of x plus 27, where x is a set of real numbers. So f of x, write f of x in the form of that, where a and b are real constants. So here I said that if you have something similar to the quadratic equation, you can look at the relationship between here and here. Now the common factor of 3 to the power of 2x and 3 power of x is 3 power x. Now this can be changed into 3 power x squared minus 28 3 power of x plus 27. So we can replace 3 power x with y, so that f of x is y squared minus 28y plus 27. Let f of x be 0, and solve the following equation as you would do with normal quadratic. I'll use the factorization method. So minus 27 minus 1, so y minus 27, y minus 1, but we replaced the 3 power x, so we have to say that but y equals to 3 power x, so 3 power x minus 27 and 3 power x minus 1. So here a is 27 and b is minus 1, plus 1, so without minus, where they are real constants. Now the part B says to use the second part of the question, the first part of the question, to find the two roots. So what we would do here is that the two products are set to be equal to 0, and 3 power x is 27 and 3 power x is 1. So in here x is equal to 0 and here x equals to 3. Now I hope this helped you, and I hope that you'll be able to do the exercise 2e. Also look around the internet for some function questions like Maths Genie.